Hi to everyone. The topic name is Distributed File Systems, presented by Ajay Gupta, Arun Chandra and myself Sunil Kamaraju Gedda. The overview of a distributed file system is, it is a file system whose clients, servers and the storage devices are dispersed among the machines. Service activity has to be carried out across the network. Instead of the service activity carried out on a single centralized data repository, the service activity is divided and spread on a multiple and independent storage devices. And here comes the definition of a distributed file systems. The definition is implementing of a common file system that can be shared by all the computers in distributed systems. Resources on a particular machine are local and are remote. So the resources is divided into two categories, local category and a remote category. When do we call our resources as a local category? If the resources used by a system are present on its own system, on itself, then it is called resources that are local to that machine. If the resources used by a person, by the client, are present on a different machine, then it is called as a remote machine. Goals of a distributed file system. First goal is network transparency and the second goal is high availability. In high availability is responsible for greater and higher performance, whereas the network transparency in the sense it doesn't allow you to view all the features. So here client will be using the resources from a machine, but he is not aware of the particular machine from which he is using the resource. So the machine name or the machine from which he is using the resources is hidden. We have architectural options. Architectural options include fully distributed and client server. In fully distributed, the file distributed to all the sites. And we have issues with fully distributed system. The first issue is the performance and the second issue is complexity. When it comes to client server model, we have files distributed to all the sites along with the dedicated sites that are used for a storage and retrieval. The client system, the client server is divided into two types, the file server and the client. File server is useful for the storage and retrieval, whereas the client will manage the rest of the sites that are used for file accessing. Here comes the client server architecture. So you can see there are a couple of clients requesting for a particular data or a particular file, and the request goes to a network here. Through the network it reaches to the server. So whenever a client requests for a particular file or a data, the request goes to the network, it goes to the server. Server looks for the appropriate file. If it is available in the server, then it responds to the client with the requested file. If it is not available, then it searches the cache memory and the local disk. If the file is found, then it retrieves the file to the client. Here is how the client architecture system works, client server architecture system. When it comes to different services of a distributed file systems, we have two different services. The first one is name server and the second is cache memory. Name server provides the mapping names supplied by a client into a file or a directories, whereas the cache memory It takes place when process attempts to access file for the first time. Cache memory improves the performance through the file caching, and the caching at the client side. When the client references file at a server, copy of data brought from a server to the client machine, and the appropriate access done locally at the client side. And we have an issue associated with this particular cache technique because the different cached copies can become inconsistent, so they are not a consistent here, and we have to prove the coordination. The next slides will be presented by my friends.
Hi, I am Arun. I continue this presentation. Mechanisms used in distributed file systems. Mounting. The mounting mechanism binds together several file namespaces into a single hierarchical structured namespace. Example, Unix and its derivatives. Location of mount information. Mount information maintained at clients. Each client mounts every file system. Its files move to another server. Every client needs to update its mount table. Example, Sun NFS. Mount information maintained at servers. Every client sees the same file namespace. If file name moves to another server, mount into a server only needs to change. Examples, Sprite file system. Caching improves file system performance by exploiting the locality of reference. When multiple clients modify shared data, cache consistency becomes a problem. It is very difficult to implement a solution that guarantees consistency. Bulk data transfer. Observation. Overhead introduced by protocols does not depend on the amount of data transferred in one transaction. Most files are accessed in their entirety. Common practice. When client requests one block of data, multiple consecutive blocks are transferred. Encryption. Encryption is needed to provide security in distributed systems. Entities that need to communicate send requests to authentication server. Authentication server provides key for typical data access in a client file server architecture. Client requests to access data, then client checks cache. Data present, then return data to client. Data not present, check local disk. If data present in local disk, then load data to the client cache. If data not present in the local disk, send request to the file server. The server checks the cache, and if the server cache doesn't have the data, then it issues to disk read, then load server cache. If data is present in the cache, then it will be loaded directly to the client cache. If not, the load server cache reads the data and loads it into the client cache and returns the data to client. Design issues in DFS. File replication. Duplicating files on multiple machines improves availability and performance. Placed on failure-independent machines, the main problem is consistency. When one copy changes, how do other copies reflect that change? Often there is a trade-off: consistency versus availability and performance. Atomic and serialized invalidation isn't guaranteed. Message could get lost or machine could crash.
Hi, myself Ajay, and today I am going to discuss about the stateful and stateless service of distributed systems and the desirable features of DFS. And in the stateful, a server keeps track of information about client requests, and it maintains what files are opened by the client, connection identifiers, and the server caches. And the memory must be reclaimed when client close file or when client dies. And in the stateless, each client request provides complete information needed by the server, and the server can maintain information on behalf of the client, but it's not required. And coming to the desirable features of DFS, user mobility, and it should not force a user to work on a specific node. And transparency, it should include structure, access, naming, and replication transparency. Performance of the DFS should be comparable to that of the centralized file system. Simplicity should give the same semantics as the centralized file system. Scalability should cope with the growth of nodes and the fault tolerance. It should not face a failure stop and maintain backup copies. And synchronization should not face a failure stop and maintain backup copies as the fault tolerance. And the security issue, and it should protect files from network intruders. And for the heterogeneity, it should allow a variety of nodes to share files in different storage media. And I took the Sun Network File System NFS as a case study to describe the distributed file system, and it is developed by Sun Microsystems to provide a distributed file system independent of the hardware and the operating system. And coming to the architecture of NFS and virtual file system, coming to the architecture of NFS, virtual file system VFS, file system interface that allows NFS to support different file systems. VFS on the remote server initiates file system operation locally, and the requests for operation on remote files are routed by VFS to NFS, and the requests are sent to the VFS on remote using the remote procedure call and the remote and the external data representation. And another term is vnode, virtual node, and this is a network-wide vnode for every object in the file system. And vnode has a mount table, allowing any data to be a mount node. And coming to the architecture, and it is divided into two departments, client department and the server department. And in client department, system calls interface, from where the client accesses the server for a certain function, and from this it is routed to VFS interface, which is virtual file system interface, and from there it's subdivided into three categories like Unix 4.2 file systems, NFS client, and the other types of file systems. I mean, Unix 4.2 file system, it's routed to the disk to access the data, and from NFS client it's routed to RPC or XDR, which is the remote procedure call or the external data representation, and from there it is routed to via network to a server side, and again to RPC or XDR to the NFS server and to the VFS interface, which you have seen from the client side, same as the server, and from the Unix 4.2 file system onto the disk. And here I am going to explain about the caching property of DFS in NFS. And caching done in main memory of clients, caching done for file blocks, translation of file names to vnodes, and the attributes of files and location. And caching of file blocks, caching cached on data with timestamp of the file when last modified on the server, and the entire file cached if under certain size with timestamp when last modified. After certain age, blocks have to be validated with server. And delayed writing policy, in which modified blocks flush to the server after certain delay. And caching of file names to vnodes for remote directory names, and it speeds up the lookup procedure. And the caching of file and directory attributes, updated when new attributes received by the server discarded after certain time. Thank you.